Welcome to the class on Geology and Archaeology, Interdisciplinary Approaches. Today, as we know, no discipline can stand alone. Interdisciplinarity is the best approach. Let us look at how geology and archaeology are related to each other. So, first we need to understand how and what archaeology is and how archaeology is related to different disciplines, be it the human sciences, the social sciences and natural sciences. You are already familiar with the earth sciences and geology is one among them. So, the objectives of today's presentation will be to try and understand the interrelationship between geology and archaeology. Secondly, to understand the interdisciplinary nature of archaeology and to know a discipline which is a combination of these two, and that is geoarchaeology. So, what is archaeology? There are many definitions. As you know, geology is the study of the earth, the history of earth, about 4.6 billion years old. What does archaeology study? Archaeology studies the human past from the material remains or material records. In the long history of the earth, human beings were the last to come. Very recently they came, and about 99% of the human past falls in prehistory. In both the historic as well as the prehistoric period, there are material remains found in the archaeological sites called the artifacts. We also get ecophags. The context is very important, and this context is provided by other disciplines, particularly geology. Archaeology is considered by many as a discovery of treasures from the past. So, you must be wondering, is it full of treasures? The material remains that we unearth scientifically and systematically from the sites, they are very rare, and hence many of them qualify as treasures for the public. But archaeology does not end with the discovery of treasures from the past. This activity is followed by the meticulous work of a scientific analyst, and then comes a very important part of analysis and interpretation, which involves the exercise of creative imagination. So, archaeology is not something that happens only in the field with lot of physical activity, but there is a very tedious, very patient, very long study that takes place in the laboratories. So, as we know, since geology studies the history of earth, archaeology studies the human past, mostly from the material remains. There are many related disciplines for archaeology because it is hugely interdisciplinary in nature, but geology has the longest history of association with archaeology. So, in the absence of written records, fossils and rocks provide clues to date the past. So, this dating, the notion of time, that is something in common to both geology and archaeology. The notion of time is what keeps these two disciplines together. It would be incomplete to think that geology alone has contributed to the concepts, methods and techniques in archaeology. It has borrowed from many other disciplines, anthropology, art history, history, chemistry, technology, museology, palynology and botany, paleontology, zoology, philosophy and psychology, and so on. So, you must have already understood that archaeology is interdisciplinary in nature. Now, what do we mean by this word interdisciplinarity? It means adopting the knowledge and methods from other disciplines. So, in short, archaeology adopts the knowledge and methods from the disciplines which we have just seen, and these are then applied to the study of the human past. But in order to do the study, these methods and the knowledge have to be integrated into archaeology. So, this interdisciplinarity was not something that emerged in the beginning of this discipline in the 19th century. When archaeologists went to the field and they conducted a lot of excavations, explorations and field work, they had some problems, they encountered problems and they could not solve with the methods that they were following at that point of time. So, they started looking beyond their discipline, looking for solutions in other disciplines. So, lot of the problems associated with archaeological sites are related to rocks, petrology, minerals, pedology, geomorphology, etc. So, it was natural that archaeology would look towards geology to solve many of the problems. So, this interdisciplinarity started as a problem oriented approach, but it did not stop there. It developed into an integrated approach, where not only ideas and concepts from geology, but many other disciplines, many other related disciplines, be it geography, chemistry, physics, all these were integrated. So, no discipline stands alone. Most disciplines today are moving towards interdisciplinarity. Archaeology has just started it early on. Now, today with this brief introduction, we will be looking at 3 questions. These questions would be: why should we study the human past? The second will be, what is geoarchaeology? And the third one, what are the methods that archaeology borrowed from geology? So, the first point that we need to understand is, why is there a need to study the human past? The answer is very simple. It is to have a better future. The greatest crisis that we face now is the climate change. Now, climate has also changed in the past. For example, about 35,000 years ago, the climate was getting warmer and there was abundant vegetation at the end of the ice age. And what was the response of the humans? The societies then, they shifted from bulky heavy stone tools to small chipped stone tools, also known as the microliths. Similarly, again, by the end of the 2nd millennium BCE, dryness or arid climate was a major cause for the collapse of most Bronze Age civilizations in the world, including the Harappan civilization. Again, we see a response. The famous cities and towns like Mohenjo-daro, Harappa, Dholavira, we see these have been abandoned. There is depopulation. The population migrated. they went to the rural areas. Rural sites emerged. Rural sites are more resilient to the climate change. They even shifted their diet patterns. They shifted to more drought resistant crops. So, wide variety of responses are there, and when we study the human past, then we can have better responses to the crisis that we face today and plan for a better future. With that understanding, let us move on to how a geologist can practice archaeology and contribute to archaeology. What is meant by geoarchaeology and what is archaeological geology? Is it the same or is it different? Now, archaeological geology was the term coined in the early 1970s by an archaeologist named Colin Renfrew, and he meant that a geoarchaeologist or an archaeogeologist is somebody who uses methods and theories that originally developed in the earth sciences, mainly geology, geography, geophysics, etc. He went on to say that this major subfield or a subdiscipline is at the interface of geology and archaeology. So, what is geoarchaeology? It is a specialized subfield of archaeology which is gaining broader acceptance within geology. It is a recent discipline and it has lot of scope for development. So, the geologists, at least some geologists would be working on these geoarchaeological projects. Now, there are many applications. Now, one of the early applications of geoarchaeology or what the geoarchaeologist was doing was to understand the site formation processes, because most of the activity of an archaeologist happens in the field, in the archaeological field, and they work in the archaeological sites where they would excavate or they would be exploring and they will be getting material, artifacts will be there, ecofacts will be there. So, in order to understand what we have got, which period, time, as we mentioned before, the notion of time is very important, equally important to the archaeologist and to the geologist. So, we need to understand how the site has been formed, and that is known as the site formation process. There are many site formation processes. It refers to the events that created and affected an archaeological site before occupation by humans, during its occupation by humans, and after its occupation by humans. This crucial information is necessary for the interpretation of context, and without context, material record may not be able to reveal much about the human past. It is also necessary to understand the physical context from which these artifacts are obtained. And site formation processes have been classified into two: the cultural formation processes CFP and the natural formation processes or NFP. Now, in this diagram what you see is, you see a sealing layer on top which is colored green, and then you see a light green second layer. Now, in geology, layer and stratum is very important. We will be discussing that after some time. So, in the second layer we see a post hole can be seen, and in the post hole it is a hole which is meant to insert a post, in this case a wooden post. So, when this site was occupied by humans, at that time they erected this post hole and there was a post inside made of wood. The wood being organic, after a while it got destroyed. Now, what do we see in the archaeological site when we go there? we will not see the wood because it is gone, and in the place of that wood there will be some soil which would have run off and weathered. All the soil would be found there, which will be of a different composition, which will have a different color nature compared to the other layers. So, these kind of information, it is very, very important in dating the site and in understanding what was going on in the site. So, in the late 1970s, Hassan, he sought to broaden the use of geoarchaeology. He said, what are the applications? The applications got widened, not just site formation processes. Geoarchaeologists started contributing to the prospection of archaeological sites, the discovery of archaeological sites, the study of raw materials with which these artifacts are made. And then once you know the raw material, once you have named it, then you can try to understand the procurement range of these human societies and also do provenance studies. For example, there was rouletted fine ware found in the early historic sites in India, and it was found in the early historic port settlements in the coastal region. So, it was assumed that it has come through trade and exchange networks. But from where did this come? So, since it was a coast and there was a lot of maritime contact with the West Asia, with Egypt, the Red Sea, the Mediterranean Sea, since this was a fine ware, it was immediately assumed that this has come from somewhere in the West. But later provenance studies were done in the 1980s, and then we found that this clay is from Ganga basin, it is from Bengal in India. So, provenance studies make a lot of difference in how we understand past human societies, how we understand the trade and exchange networks that they had. It also helps to create models, generate models on cultural interactions, environmental interactions, etc. And one of the most important aspects or domain where geoarchaeology can contribute is geochronology. Now, how is geology applied in archaeological studies? Lot of rocks and minerals are found in the archaeological sites. So, geology benefits a lot in understanding how these rocks and minerals have been used by past human societies, because these have served as basic raw materials for human activities, and it is the presence of these natural resources that defined where the human beings would like to settle. So, it influences their settlement pattern, it influences their subsistence strategies, it influences their level of technology. For example, pottery is very commonly found in archaeological sites. In fact, it is the most common artifact found in archaeological sites, ceramics or pottery, and that is made of baked clay or terracotta, and then it is mixed with chaff. In this picture you can see rice chaff in the ceramic found from a site in southern Oman. The presence of chaff suggests rice cultivation. So, it is not the pot is not identified purely on the basis of its morphological or form or shape or its function. Much more can be understood about the earth from these archaeological artifacts. So, apart from these, there are many broad theories and methods borrowed from geology by archaeology. I have listed a few here. These include the principle of uniformitarianism, the principle of stratigraphy, the law of superposition, then geochronology, and finally geophysical techniques. First, let us look at the principle of uniformitarianism. This was proposed by an 18th century Scottish geologist James Hutton, and he said, his famous quote is, "The present is a key to the past, and the past history of our globe must be explained by what can be seen to be happening now." So, if we look at the present, you can observe a lot. You may not be able to observe all this in the past, but you can get certain clues from the present, what you have observed, and you can use it as a key to open the past. So, he later developed this into the principle of uniformitarianism. It means the geologic processes observed in operation that modify the earth's crust at present have worked in almost the same way over geologic times. This is the principle of uniformitarianism. The second one that we discuss is of immense importance in archaeology. It is in fact one of the most important relative dating technique used in archaeology, and that is known as the principle of stratigraphy. Stratum means layer in Latin, and stratigraphy is used to determine relative age analysis of position of the layer. So, as I said, it helps us in relative dating. There are many methods of relative dating. We have already discussed that notion of time is very important, and dating is an important process in both geology and archaeology, and stratigraphy is a relative dating technique used in archaeology. The principle is very simple. Objects found in the same undisturbed stratigraphic horizon are perceived to have the same age. So, we have to first identify the stratigraphic horizon, and if it is undisturbed, then the entire layer will have the same age. For example, in a vertical excavation trench, we come across a coin of the Mauryan dynasty, and we also find some pottery, say northern black polished ware, in the same layer. So, in that layer we have found in the cultural layer, in an archaeological site, we see some artifacts. We get a coin, we get a pottery. Now, we do not know the date of the pottery, but we know the date of the coin, and then using this principle we can confidently say, if it is an undisturbed layer, that all the artifacts that we get from this particular layer, all of them are as old as the coin. So, we can easily date. So, this is this principle has got tremendous application in archaeology. Now, the third one is the law of superposition, which says that in an undisturbed sequence of rock layers or sandy layers that we find in the site, archaeological site, the bottommost layer will be the oldest and the topmost layer will be the youngest. So, the bottom depositions are older and the top depositions are younger, but when we excavate, we are exposing the top layers first, then only we can reach the bottom layer. So, when we are excavating, as we go down, we are going to the older layers of humanity. So, we can say the layers young from the bottom to the top. Now, the next important application that we have to discuss is geochronology. We can discuss that in greater detail later, but from the word chronology we can understand that we are referring to the notion of time and dating methods. The difference is these are not relative dating methods, but absolute or chronometric dating methods. The most common one used in archaeology being the carbon 14 or the radiocarbon method. Another method of geochronology is archaeomagnetism. And the last point regarding the relationship between archaeology and geology are the geophysical techniques. There is no excavation or no archaeological field work that takes place without geophysical techniques. These include survey techniques. These again can be divided into two: the geological drilling methods and then the use of probing devices. The probing methods can be invasive or non-invasive. There are different probing methods, techniques such as the magnetic, electrical, seismic, radiometric, the gravity method, and the use of machines like ground penetrating radar, etc. So, now let us look at the sample of a geological report. This is on a rock shelter, Edakal rock shelter, which is in the Western Ghats. It is in Wayanad district in Kerala. So, the geology report reads that the rock shelter is found in intrusive igneous rock or granite, which has penetrated the metamorphic rock, which is more widespread in this region. And the massive granite is pink with good amount of the following minerals: pink, feldspar, quartz, hornblende and biotite mica. The granite shows sharp contact with granitic gneiss. The rocks here in the rock shelter are highly weathered and dissected. Thick layer of regolith covers the parent rocks, which is due to chemical and mechanical weathering. Then there are well developed joints seen, and also foliations are seen, which is typical of metamorphic rocks in the region. Biological weathering through the growth and decay of the roots and stems of the trees and plants which grow through these fractures have also accelerated the weathering process. Now, this technical report, this geological report is necessary to understand what are the conservation issues in the site and then protect the site. So, let us summarize what we have discussed today. Geology and archaeology are interrelated disciplines. Archaeology is related to different disciplines borrowed from the human sciences, social sciences and natural sciences, including the earth sciences. But geology has a longest history of association with archaeology. Archaeology is interdisciplinary, meaning it adopts the knowledge and methods from other disciplines and applies these to the study of human past and uses an integrated approach. Landscapes and environment can be recreated through studies of geomorphology and sedimentology embedded in geology. Geology is used to analyze the deposits found in the surface that provides much of the evidence for changes in landforms over time. Geophysical and geological prospecting is crucial for the discovery of sites and for understanding the human past. Geomorphic mapping provides descriptions of the landforms, of rivers, the drainage pattern, surface deposits, tectonic features and any active geomorphological process in the past. Thank you.